Hi everyone. In previous lectures, we're trying to compile and run our code within the WSL2, which is a Linux machines. So basically, we compile with the NVCC compiler, and then we can run it. I'm using the baseline vector addition examples. For most of users, they're using Windows system, and maybe people want to compile and run the code using the Visual Studio. That is what we're going to talk about today. Let's assume you already downloaded the Visual Studio. Yeah, so for me, I downloaded and installed the Visual Studio 2019. Okay. The first thing is you can open the Windows PowerShell and check your NVCC version. So for me, I use CUDA 11.2. And also, this is my GPU, RTX 4000 ADA. So that's my GPU. Okay, so with this in mind, I want to show you how to build and run a project, CUDA project, using the Visual Studio. So let's get started. So first, you can open it. Okay, since we already installed CUDA, we can click here, create a new project, and you can search the CUDA here. So it's a CUDA 11.2. Click it and next. Okay, now let's assume the project name is CUDA Runtime 2, and you can change the solution name or not. But now I just click on this. So you can click create. It's better for you to start from an empty directory instead of the previous directory, which include the CUDA code. So you see, I built this project, CUDA Runtime 2, at the right. And also, it automatically generates a new file called kernel.cu, right? But this is not what we want. Let's right-click it and change it to vector add. So that's our vector add example. Then what we're going to do is we can copy the code of the vect add here. We just copy it and then paste it here. Control V. So after Control V, in the line 140, you will see some kind of the brackets are separated by a space. So after you paste the code into the Visual Studio with Control V, you can type the Control Z. Then it will go back to the original format. So please pay attention. Okay. So that's one point. Another point is you have to include some header files if you want to build your solutions within Visual Studio. It's a CUDA runtime and device launch parameters. Previously, in the WSL, you can comment these two lines and you can still build it here, right? But you have to add these two lines into the Visual Studio project. So I add all these header files for all the examples. So hopefully it will not bother the following users. Let's go back to the project. So you have everything here. There's one thing I want to mention is you can choose the debug or release mode, right? In the WSL, I think the default is the release mode. But now let's just choose the debug mode. And please choose x64 here. There's another parameter we want to check. It's you can right click on the CUDA runtime tool and go to the properties and click on the CUDA C++ and the common here or device. Yeah, so device here, there are code generation. So remember, this is very important. You should set it based on your GPUs on the Windows system. So if you remember, in previous WSL examples, I add the architecture is SM_89, right? So that is corresponding to RTX 4000. Okay, RTX 4000. Yeah, that's something that's I can use it here. The reason I can use it here is because within WSL, I think I installed another CUDA compiler, which is the 12.8. So basically, it's different from it's a different version from the Windows PowerShell, right? It's different from here. So that's why we can use the SM89 here, which corresponds to the RTX 4000 GPUs. However, if I try the SM89 and compute 89 here, then the compiler will throw an error. The reason is since it uses a CUDA 11.2 compiler and the RTX 4000 ADA GPU is kind of generated after that compiler is released. So that compiler has no knowledge of the, updated or the following kind of GPUs. That's why sometimes we have to change this to a lower number. So what I tried here is 86. I think 86 is already okay. So I change here, you can apply, and then okay. So then we can build it. So a quick way is to build the build solution here. Yeah. So if you see the one succeeded here, then it shows that it's good, right? So after you build it, you can start debugging and see, okay, it just prints the blocks, threads, and complete successfully. So that shows our codes can compile and run successfully. If you pay attention to my screens, you will see there's one error here. If we choose the build and IntelliSense, so here, basically, I think Visual Studio sometimes identify one, one lines or one format as kind of incorrected expressions, but actually it doesn't influence the solution building process. So if you choose this to build only, then there will be 0 errors. So what I want to say is when the criterion is when you try to build it, then if you see the succeeded kind of signal, then you're good, and then you can run it, right? So this is a process that how we can build and run our previous CUDA project into the Visual Studio 2019 instead of running it within the WSL, right? And one key point is please pay attention to your CUDA versions in the Windows system and the WSL. So in my system, I have no idea why I installed two different versions, maybe for different projects. But since if you use different versions, the key point is you have to set the architectures corresponding to that versions, right? So that is what I'm going to share in today's video. Thanks for watching, and hope to see you in the next video.